The question says P is a solution of 0.08 moles per decimeter cube sodium hydroxide, and Q is an actual solution prepared by reacting an unknown metal carbonate in an excess hydrochloric acid. When Q was prepared, 5.04 grams of the metal carbonate was completely reacted with 1.00 decimeter cubes of 0.200 moles per decimeter cubes hydrochloric acid. You are to determine the identity of X and the unknown metal carbonate by a titration. And in this titration, 25 cubic centimeters of solution P is titrated with solution Q, and the average volume is 25.0 cubic centimeters. Let us understand what is happening here. This is our solution P. This is solution P. The question says solution P is 0.0800 moles per decimeter cubes of sodium hydroxide. This is our solution P, 0.80800 moles per decimeter cubes of sodium hydroxide. This solution is obtained by a pipette, 25 cubic centimeters. This is 25 cubic centimeters transferred onto a conical flask by a pipette. This is the solution that will be titrated with hydrochloric acid. Then we are told that there is solution Q, which we are going to use to titrate this solution P, and this solution Q is prepared by reacting 5.04 grams of X carbonate with 1.00 decimeter cubes of 0.200 moles per decimeter cubes of hydrochloric acid, which we are told is in excess. Now, what you should understand here is that some of the hydrochloric acid here will react with the X carbonate to produce the salt, X chloride, water, and produce also the gas carbon dioxide. Because the hydrochloric acid is in excess, we will also have some hydrochloric acid remaining as unreacted. This is unreacted acid, and this unreacted acid will be used to titrate this sodium hydroxide. It will then react with the sodium hydroxide. This is the acid that is transferred into the burette. Then when the burette is opened, it will combine with the sodium hydroxide here, and the two will react together by a neutralization reaction. Let's move on and check out what the calculations say so that we can go over them. We are now asked to calculate the number of moles of sodium hydroxide in the volume of solution P that is used. Let me quickly remind you of the three formulae that we normally use when we deal with moles. Remember, moles equals to the mass in grams divided by the relative molecular mass. When we are dealing with gaseous substances, the number of moles equals to the volume of gas divided by the molar volume of gas at room temperature and pressure, which is 24 decimeter cubes. And when you are dealing with solutions, the number of moles equals to concentration of the solution multiplied by the volume of the solution. Since we are dealing with solutions here, this is the formula that we will be working with. So moles equals to the volume of the solution multiplied by the concentration of the solution. I've written here concentration of sodium hydroxide and volume of sodium hydroxide because you are given also the volume and the concentration of the hydrochloric acid. And I want you to note that since the question says we are to find moles of sodium hydroxide, the concentration and the volume should be of sodium hydroxide. We are given the number or the concentration of sodium hydroxide as 0.08 moles per decimeter cubes, and the volume is the volume that was in the pipette, which is 25 cubic centimeters, which translates to 0.025 decimeter cubes. You press your calculator, the answer that you get is 0.002 moles. Do not just look at this answer, take your calculator, press it, and see if you will get the same answer as mine. The next question says, the equation for the reaction between solution Q and solution P is given as sodium hydroxide in aqueous state react with hydrochloric acid in aqueous state to give sodium chloride in aqueous state and water in liquid form. And this equation balances as 1 mole of sodium hydroxide reacts with 1 mole of hydrochloric acid to give 1 mole of sodium chloride and 1 mole of water. And the question continues to say, solution Q contains the acid left in excess after the hydrochloric acid reacted with the metal carbonate. Use your answer to be and the equation to calculate the number of moles of excess hydrochloric acid contained in the average volume of Q. Use your equation, and according to the equation, 1 mole of sodium hydroxide reacts with 1 mole of hydrochloric acid. This is what you have here. 1 mole of sodium hydroxide reacts with 1 mole of hydrochloric acid. And if these two substances react in this ratio, how many moles then of hydrochloric acid will react with 0.002 moles of sodium hydroxide? Carry out cross multiplication. If you do cross multiplication, then you'll have 0.002 times 1 mole is equals to 1 mole times X. And if you perform arithmetics, you will finally get an answer of 0.002 moles. Do not just leave your answer here, write it in the space that is provided. 0.002 moles of hydrochloric acid. D says calculate the total number of moles of acid left over when 1.00 decimeter cubes of 0.200 moles per decimeter cube of hydrochloric acid were reacted with 5.04 grams of X carbonate. I want you to understand that solution Q is made by reacting 5.04 grams of X carbonate with 1.00 moles decimeter cubes of a 0.200 moles per decimeter cubes of solution, hydrochloric acid solution. Now, I want you to understand that this mass of the carbonate will react with the acid here to produce carbon dioxide, water, and a salt. Since the acid is in excess, some of the acid will remain as unreacted. So the number of moles here will reduce as the acid reacts with the carbonate. So at the end of the day, we are going to have a certain number of moles here of the acid. That number will be less than 0.2, which will be the excess acid remaining. So we'll have that number here, and the new concentration will be that number. Let me call it X. it will be x moles per decimeter cubes. So the concentration of this solution will reduce. It will reduce as the acid molecules gets used up. And whatever concentration remains here will be the same as the concentration of the solution in the burette, because the solution in the burette is obtained right from here. So we pour that solution into the burette like that, so the two solutions will be exactly the same. So if we can know the concentration of this solution in the burette, then we can easily find the number of moles that are remaining here. So let's very quickly find the concentration of the solution in the burette. We know that the volume from, or by the way, concentration is equals to the number of moles divided by the volume of the solution. We have calculated the number of moles of this hydrochloric acid in the burette as 0.002. So this will be 0.002 moles divided by the volume of the burette. We were told that the volume from the burette is 25 cubic centimeters, which converts to 0.025 decimeter cubes. Please note where I get this 25 cubic centimeters. In this titration, 25 cubic centimeters of the solution is titrated with solution Q, and the average volume used is 25 cubic centimeters. This is where I get my 25 cubic centimeters, which I use as the volume of the acid. And when we do simple mathematics, the answer that we get for this concentration will be 0.08 moles per decimeter cubes. This is the concentration of the solution in the burette, 0.08 moles per decimeter cubes. And we have said the solution in the burette is obtained from the solution in the beaker here, and these two solutions have got the same concentration, 0.08 moles per decimeter cubes. Now we can use this concentration to find the number of moles, since we know the volume to be 1 decimeter cubes. Therefore, the number of moles is equals to the concentration, 0.08 moles per decimeter cubes, multiplied by the volume, which is 1 decimeter cube, and the answer that we get is 0.08. 0.08 moles. Another way of doing this question is to say the 25 cubic centimeters of solution in the burette is found to contain 0.02 moles, 0.002 moles. Therefore, 1 decimeter cubes, which is 1000 cubic centimeters, will contain how many moles? Then you do cross multiplication. By cross multiplication, we will have 1000 cubic centimeters multiplied by 0.02 moles, 0.002 moles divided by 25 cubic centimeters, 25 cubic centimeters, giving us the number of moles that we want. I want to spend a little bit of time here and explain something to you in relation to the calculation that we did earlier on. And I want you to note the 0.002 here divided by 25 cubic centimeters. This is the same as the 0.002 here divided by the 25 cubic centimeters. This is where we say the concentration of the solution in the burette. This is concentration in the burette. The concentration in the burette. And then from there, you take this concentration in the burette, multiply it by the volume in the beaker to obtain your number of moles, which is this calculation over here. So it is very important to know the principle of dilutions, to know when two solutions will have the same number of moles, to know when they will have the same concentration. Let's move on to question number E. E says the number of moles of hydrochloric acid in 1.00 decimeter cubes of 0.200 moles per decimeter cube hydrochloric acid is 0.200 moles. It is easy to see why. The number of moles equals to the concentration, which is 0.2, multiplied by the volume, which is 1.00. You will get 0.200 moles. Use your answer to D to calculate the number of hydrochloric acid that reacted with 5.04 of the carbonate. Okay, at the beginning we had 0.2 moles, and then we used 0.08 moles. So how many have we used? Via subtraction, we have 0.120 moles of hydrochloric acid. There is one, especially that you are told that you are to use your answer to D to calculate the number of moles. Make a habit of writing your answers in the spaces provided, otherwise you will be regarded to have missed or omitted such a question. The next question says, the equation for the reaction of the metal carbonate with hydrochloric acid is X carbonate in solid form plus 2 moles of hydrochloric acid in aqueous form gives aqueous X chloride plus 1 mole of water plus 1 mole of gaseous carbon dioxide. Use your answer to E and the equation to calculate the number of moles of metal carbonate used to prepare solution Q. According to the equation, 1 mole of the carbonate reacts with 2 moles of the acid. 1 mole of the carbonate reacts with 2 moles of the acid. And if 1 mole reacts with 2 moles, then how many moles of the carbonate will react with 0.120 moles of the acid? By cross multiplication, X times 2 is equals to 1 times 0.12. And if your math is right, you should get 0.06 moles. 0.06 moles. Make a habit of writing your answers in the space that is provided. 0.06 moles. G says use your answer to F and the mass of the carbonate. The mass of the carbonate, remember we were given as 5.04 grams, used to calculate the RMM of the carbonate. According to the equation, moles is equals to the mass in grams over the relative molecular mass. And the number of moles, we have calculated that as 0.06 is equals to the mass in grams, which is 5.04 grams, divided by the relative molecular mass. Make RMM the subject of the formula, and you have mass in grams 5.04 grams divided by the number of moles 0.06. And if you press your calculator, you should get the answer 84. Make a habit of writing your answers in the space that is provided. The question says relative molecular mass. Relative molecular mass, you leave it as no units or without units. The only time you write units is if the question says molar mass, the mass of 1 mole of a substance. This is when you would write the units as grams per mole. If it just says relative molecular mass, you leave the answer without units. Then H says use your answer to G to calculate the relative atomic mass of X and identify X. The relative molecular mass of the carbonate is 84 according to the calculation. So this means the mass of X plus the mass of carbon, which is 12, plus the mass of the 3 oxygens should give us 84. The 3 oxygens give us a total of 48. And 48 plus 12 gives us 60. Therefore, X plus 60 is equals to 84. So that means X is equals to 84 minus, this is 84 minus 60. Therefore, X is 24. Make a habit of writing your answers in the spaces provided. Relative atomic mass 24. And from the periodic table, the element with atomic mass 24 is magnesium. Therefore, metal X is magnesium. The question just said identify. It did not say write the symbol. Neither did it say write the name. So this means any one of these two is correct. You can write the symbol Mg or write the name magnesium. Thank you very much for watching. See you at our next revision lesson.